Okay, done. Start. Welcome to students. Today we observe the concept of learning on the concept of refraction of light at curved surfaces. What we observe in the concepts and what is the meaning about lens, what are the classification of lenses. Now, for that to understanding the refraction of light at curved surfaces. Now, did you ever observe the while we going to watch repair shop and also telescopes, cameras and microscopes, and even though simple microscope, that is a magnifying glass, when we observe in the case of dermatologist and also that is astrologist, when we observe the astrologist to observe the palm of at the time of viewing, that is the watch glasses, also nothing but magnifying lenses. That magnifying lenses, what is the main purpose and what are the different types of lenses are there? Those lenses, though used in our daily life, what are the importance those lenses in our daily life? Now to understand how the refraction or working of refraction of curved surfaces. Now understanding this one. Now introduction about that lenses. Lens is lens is a refracting medium. Now did you observe this one? Did you observe the watch repair shop and this one also? In the case of microscope also, different lenses are used in different ways. Even though now this one having a lens, the refracting surfaces, it bounded by two refracting curved surfaces. It is a convex lens. It is a convex lens bounded by two surfaces, curved surfaces. And also a middle part is thicker when compared to that of edges. It's a thin. So that is called as a convex lens. Now you ever observe that one, even though in our elder people's nothing but grandfather, grandmother do daily newspapers to observe. Now in the case of observation of newspapers, you must be wearing of spectacles. Which type of spectacles are used? That is, what is the purpose? Different, even though children are also used the spectacles. Those what type, because of having suffering with some eye defects, that is the myopia and hypermetropia. For example, now the grandfather observe the newspaper, in the newspaper to observe what are the letters can be appear to enlarge. Generally normal with is blurred, but observe in the case this one is enlarged, clear images. Having because this is suffering with some hypermyopia and hypermetropia defects. Hypermetropia means the person suffering with hypermetropia, he can observe that is long objects, long distance objects, but not near objects. So that's why the grandfather and elder people must be wearing of reading glasses also. And in the case of children, evenly students are mainly observed, spectacles must be wearing. Those are myopia, because those are observed. That is also called as short-sightedness. Short-sightedness means the person, he can observe near objects but not far objects. So even though on the blackboard, that's when I teach, while my teacher writing on the blackboard, the near objects, that is in front of the blackboard, that's nearer to the bench, persons must be observed, but not last bench you cannot observe, because of the person does not observe the long objects, only near objects must be observed. So it is a myopia. Now even though now observe the different types of lenses are also there. So what are the refraction of light at curved surfaces? Now observe. Now this one, refraction of light at curved surface. And also different types of lenses must be there. You know what is meant by lenses. So what are the lenses? Lens is a refracting medium. Lens is either. Now observe the transparent material bounded by two refracting surfaces. One is two surfaces, that is a curved surface. But in the case of one is a plane surface, another one is a curved surface. That means the transparent material. Now different is a convex lens, this is a concave lens. Convex lens means bounded by two surfaces at bulging at middle part when compared to edges. But in the case of the concave lens, the middle part having thinner than compared to edges. Now that's what is called convex lens, is also concave lens. Sometimes called as a convex lens and is also called a converging lens. Why it is called as converging lens? Because the light rays come from the object from at infinite distance, the parallel rays and incident on the convex lens. Those are meet at a point. Converging means meet at a point on the principal axis. So it is called converging lens. Now, converging also converging which are thicker in the middle and thinner at the edges. Why? In the case of concave lens also, the concave lens have the diverging lens because the light rays are moved away from that. That's why diverging lens. Concave lens also called as diverging, which are thinner at the middle and thicker at the edges. Now these are the, and also different types of lenses are there. Now observe the biconvex lens, biconcave lens, plano-convex lens, and plano-concave lens, concavo-convex. That is a biconvex. You know, biconvex means having two surfaces, two curved surfaces. But in the case of biconcave means at the middle part is thinner than edges. The two curved surfaces are inwards, bulge inwards. The plano-convex. Having surface is a plane, one end, and other end having the curved surface. That is the plano-convex. In the case of plano-concave, plano-concave means one surface is a plane, the other surface is a curved inward. That is the plano-concave lens. Now again, concavo-convex. Concavo-convex is a surface. The surface having one surface having concave, the other surface having convex. So that's why concavo-convex. These lenses are used in our daily life also. In the case of now, what are the important concepts in the center of curvature? Different definitions about center of curvature, radius of curvature, focal length, and pole, and sometimes they are also called as focus. Now, what are the some important concepts for in the while examination point of view? Either 1 mark question, 2 mark questions are there. Now, understand the concept of center of curvature. Now, center of curvature having two spherical surfaces, having two different curved surfaces. Two circles are having center of curvatures. Those are intersected to curve, that is to form a convex lens. That is a biconvex. They have two curved surfaces bulging out. A light ray are passed to center of the curvatures. That is called the principal axis. That is called principal axis without any deviation. Without any deviation. Again, you know radius of curvature. The radius of curvature means that point, the distance between the center of the sphere to the point on that curved surface, it is called as the radius of curvature. Radius of curvature. Now, for the radius of curvature, the distance between center to radius, center to point at edge, that is the radius of curvature. Now, this is the radius of curvature. Okay. Sometimes the relation between the focal length f is equal to focal length, it is denominator small f, radius of curvature. Is capital R. Now, focal length f is equal to radius of half of the radius, f is equal to r by 2. F is equal to r by 2. From this expression, r is equal to 2f. Most important, r is equal to 2f. Now, focal length f, the distance between the pole to focus, this is having the pole P. This is called focus. The distance between the pole to focus is said to be focal length. So all measurements, distance measured from the pole to focus is said to be focal length. So half of the radius is said to be focal length and r is equal to 2f. Now radius of curvature, what is the relation in the case of 1 mark or half mark bit is there? That is, what is the relation between focal length and radius of curvature? F is equal to r by half of the radius is said to be focal length. Okay, next one. Now, radius. Focal length of the lens. Now observe this is a lens having the eye lens is a convex lens. It is a convex lens. The convex lens having sometimes the ray diagram, while drawing of ray diagrams, the important concepts are the nature of the image, and that is the position of the image and relative size of the image. These important are there while drawing of ray diagrams of the concave lens and the convex lenses. What is the nature of the image? That is, what are the nature means? It is a real image or virtual image. Position of the image. What is the meaning of position? The image can be formed at which, and also relative size, that is a bigger than or smaller than, or either magnified or diminished. These important points are there. It is also convex lens, sometimes called as converging lens. You know, it is also simple microscope and magnifying lenses. This is a concave lens. It is a diverging lens. Now, what are the positions? At different positions of the images, objects at different images are formed. While in the case of concave lens, when a light rays comes from the object, those are parallel to the principal axis. After refraction, those two light rays are diverged. But we understanding, when the two diverging light rays are backwards extended, those are meet at a point. That is, point is called focus. The point is called focus, at which the image is formed. That image is always virtual, erect, diminished. In the case of examination point of view, which lens forms always virtual, erect, diminished image? That is concave lens. Okay. Not all that's one. This image form at image is formed at focus only. Now again, in the case having the some important concepts while drawing of examination pattern, any light ray parallel to the principal axis, that must be passed through focus. Passed through focus. So while in the case of convex lens and the case of at the same time concave lens also, all light rays are parallel to the principal axis, must and should follow the focus. At the same time also, that is parallel to the principal axis, that is focus. Now in another case, important thing, and certain angle with the principal axis, that is must be passed through focus. After refraction, it is parallel to the principal axis. In the case of convex lenses, in the case of concave lens, same manner. Now again, another light ray pass the principal focus, that is the optic center without any deviation. In the case of convex lens, that light ray cannot be deviated. The two important things is one is parallel to the principal axis, that is along the principal axis, the light ray cannot be deviated, and at the same time the light ray at the optics pass through optic center cannot be deviated. The two important points must be remembered. Now again, what image formation of the lenses? So image formation, how the image is formed in the case of convex lens and also concave lens. Now the different situations, the object is situated at different positions. That is the object at infinity and position of the image, relative size of the image and nature of the images. These are the important for that. Now at infinity, at focus, at what is the real and inverted images? Erect also. Virtual, real, virtual, inverted and erect. Real means the image can be captured on the screen is said to be real image. Virtual image means the image cannot be captured on the screen. That is said to be virtual image. Now erect means object like the object look like in vertical position only. But in the opposite, the vertically inverted. Different nature of the images can be observed at different positions of the object. Now understanding that at different positions of the object is situated in front of the convex lens. Now the first case is there. It is a convex lens. This is a convex lens. The object at infinity. What is the image formation position? What is at which the position of the object, image, and relative size of the image and nature of the images. Understanding for that. Diminished, highly diminished, and nature of the image is real, vertically inverted point size. Now the light rays come from the object at infinity. Now these light rays are said to be parallel rays. The first light ray, second light ray, third light ray and fourth light ray. 1, 2, 3, 4 are parallel rays. But these 1, 4, these two light rays are said to be marginal rays. And also 2, 3, these two rays are said to be paraxial rays. paraxial rays. 1, 4. These are margin because the light rays are moved away or far away from the principal axis. Those are called as marginal rays. The light rays nearer to the this is the principal axis. This is the principal axis. Nearer to the principal, those are called as paraxial. So this is the principal, and the light rays which are nearer to the principal axis, those are called as paraxial rays. Okay, thank you. Now again, and then the second positions, object at beyond the center of curvature. Beyond the center of curvature. Object at beyond the center of curvature. What is the position of the image and the relative size of the image and the nature of the image is understanding. Now, object is situated beyond the center of curvature. The image is formed between focus and the center of curvature. That is minimized. That is diminished image can be formed. While we are drawing up examination pattern also, I can while explaining the diagram also. At focus. At the first one at infinity, at second one beyond center of curvature. Third case is at center of curvature. At center of curvature, the object size must be is equal to that image size. To understand, object at 2f1 and object position of the image 2f2, and the relative size also 2. The nature of the image is similar to that object. Now case 4, object between f1 and 2f1. That means object is beyond, between the center of curvature and focus. That is, the image is real and vertically inverted, enlarged. Object is size is when compared to the image size very bigger than that object. One is the two light rays are there. The two light rays, one is parallel to principal axis, another light ray that is positive to the focus. That is a positive optic center. Those are meet at a point at which the image is formed. What is the type? What is the size of the image is maximized? That is maximized or enlarged. What is the nature of the image is real, vertically inverted. The arrow mark must touch while drawing of examination point of view. That is real and vertically inverted. Arrow mark must touch when the light rays. And again, the object at focus. The object is at focus. At focus, the image is formed at infinity. This is the relative, that is the opposite to that of first case. Now, at first case, object infinity, image is formed at focus. Now, in this case, object is situated at focus. The image is formed highly enlarged at infinity. Because of two light rays are parallel rays. Two light rays are parallel. That is real and inverted. The last case is sixth case. That is the object is situated at between the focus and optic center. Now, what is the position of the image is on the same side of the object. Now, understanding the object. This is the image. Now, this is called in the dark, not a dark line. It is a dotted line. Dotted line means virtual image. What is? While the drawing of examination of pattern of ray diagram, it is all the light rays, that is the virtual to identify indication of real image. Real is dotted line, but virtual image compulsory to indicate dotted line. That is a dotted line. Okay, to identify is a virtual and also erect. Virtual and erect. Okay, this one, the case is also belongs to that of simple microscope, and also dermatologist must be observe the body, and also astrologist must be observe the form by using that magnifying. This case must be there. Okay, now some other examples of now again while the case of concave lens also. Concave lens, how the position and the nature of the image while the case of concave lens, it is very difficult case. But in case, observe all the objects beyond the center of curvature, at center of curvature, at focus. But if you observe, this in all cases, the image is always virtual, erect, diminished image, or position of the object at infinity. But observe at focus. At focus, that is point-sized diminished image, virtual. Highly diminished point size, that is virtual image. Virtual and erect. This is the case 1. And also at case 2. Between infinity or center of curvature at focus. Between infinity and optic center of the lens. What happened? What we understand? Now, the right case, between focus and optic center, the image also virtual, erect, diminished image is formed. Now, these are concepts, but these are audio visual, but also we having some more concepts on that. Now, the concept on this one, the diffraction of light at curved surfaces, understanding the topics of the formation of the images. The same, different definitions of the game. Formation of the image by the lenses. A lens is formed when a transparent material bounded by two surfaces, of which one or both surfaces spherical. By convex lens and by concave lens and by concavo, that is a plano-convex and plano-concave. Plano-concave and plano-convex lenses. These are the definitions about that while the drawing of examination. Lens, 1 mark questions or 2 mark questions are there. Lens, biconvex lens, biconcave lens, plano-convex lens and the plano-concave lenses. Okay, and again, the diagrammatic representation of lenses, most important in the 2 mark question and 1 mark questions are. Now understanding this one, the diagram biconvex, biconcave is a plano-convex, is a plano-concave and concavo-convex. These are most important this examination point of view. This question is given to 2 marks question. The differences between, what are the differences between the convex and the concave lenses? Convex and the convex lenses. Now this type of any difference in the questions when the drawing of writing of examination, the differences must be right at. What are the differences? Thin center and thin at edges, the underlying points, and thin at the center, thick at the edges. And also this is called converge. The convex lens, this is a converging lens, this is a diverging lens. To identify the important points, mainly to underline that points. And again, the symbol, it is the most important. Convex lens can be represented as upward arrow, downward arrow, combining of upward and downward arrow. While the case of concave lens, this is the concave lens, most important. So, and again, it is enlarged. The objects are seen through a convex lens is enlarged. Now, in the case of diminish, this is the diminish. Now, this lens used to correction of hypermetropia. Correction of hypermetropia, while the concave lens is to correction of myopia. This is important. This is a hypermetropia, and this one myopia. So these are the main points to underline the concepts. Now again, what are to understanding? Now again, definitions about the center of curvature and radius of curvature and focal length. Center of curvature, the center of the sphere at which contain the part of the curved surface is called the center of curvature. It is denoted by letter C. And the radius of curvature, the distance between the center of curvature and curved surface is called radius of curvature. And focal point and focus, the point of convergence or the point from which the rays seem emanate to that called is the focus. You know the relation between, what is the relation between the radius of curvature and focal point also? In the radius of curvature, R is equal to 2F. R is equal to 2F from F is equal to R by 2. F is equal to R by 2. This is most important. Like a focal point, the light rays are converge. The light rays are converge or converging point. And the rays through emanate are, in the case of convex lens converge, in the case of concave lens is the diverge. This is most important. Now okay. Now again, the definitions about the focal length The distance between the focal point and the optic center is called focal length. And optic center, the midpoint of the thin lens is called optic center of the lens, and sometimes called as a pole. The principal axis, the line joining the center of curvature and the optic center of the lens is called principal axis. Now, the image formation of convex lens at various positions of the object, and the ray diagram must and should object at infinity. And what are the characteristics in the case of 4 marks questions? That's the most important question. What are the position of the image? What are the position image characteristics? The object is situated at different positions on the principal axis. First one is at infinity, and second one is beyond the focus, beyond the center of curvature, at center of curvature, between the center of curvature and focus, at focus, and pole to focus. What are the image characteristics of that relative positions of the object? Now, the first case to understand the object at infinity. The object at infinity, what is the position and the image? So, at the object at infinity, the light rays are parallel light rays comes from the object. Those are after refraction. Those are meet at a point at focus on the principal axis. Now, what are the characteristics of the image? The characteristics of the images are, the first one is a point size real image at focus. This is most important, at focus. Now again, object at beyond the center of curvature, beyond the center of curvature, object beyond the center of curvature. The image, this is the ray diagram. While drawing of the ray diagrams, you must follow that very simple manner. That is the points must be, when a line is drawn, and to indicate the point by using pencil and having the differences, same difference to maintain the points. For example, if you are drawing this one, when you are drawing exam line, this is a symbol for convex lens. This is a pole. By using scale, point to this one. For example, is a focus. The focus having 5 centimeters. Why 5 centimeters? At the same time, similarly, again 5 centimeters we point denoted is also 5 centimeters. Center of curvature. And again this one, by using scale, having the point indicate at focus. This is F1, C1, F2 and C2. Same. The point indicated very easily to draw the diagrams simple manner without any deviation. This is most important. By using scale to point out the focus, pole to focus, nearly 5 centimeters. And the object, where the object is beyond the center of curvature, now that light rays, 2 light, how many light rays are needed for the formation of the ray diagram? Must and should 2 light rays are needed. One is parallel to the principal axis, another light ray that is passed through optic center without any deviation. These 2 light rays after refraction, what happening? These 2 light rays are after refraction to form the image. 2 light rays intersect at which the image is formed. Further, now, what are the characteristics of the image? The characteristics of the image is a real, inverted, diminished image. Real, inverted and diminished image between F1 and 2F1. That is real, okay, because it can be captured on the screen. But in the case of diminished, when compared to the object, it is very simple, smaller. So that's why real, inverted image. And again, case 3, object placed at the center of curvature. The relative positions of the object and image both are same. So that's why, what are the characteristics of the images are the real, vertically inverted, same size of that object. Now case 4, between the center of curvature and focus. Between center of curvature and focus. The objects are there. Now between the center of an object, the 2 light rays are after intersect. It is an enlarged image. Real, vertically inverted and magnified image is formed beyond the center of curvature of the after the lens. What are the characteristics of the? Must and should write the characteristics of the image of the object. Real, inverted and magnified image is beyond the F1. And case This is a fifth case. Object focus located at focus. That is object at focus. This the image is formed at infinity. Highly magnified, also real, vertically inverted. The image is formed at infinity distance. Okay, now the object is situated between focus and optic center. This is the case of a simple microscope case and also magnifying lens. In this case also is a dermatologist to identify the scabies or any bacteria on the skin by using this case only. And also astrologists must observe the palms and other thing by using magnifying lens and a simple microscope. This is a simple microscope case. What are the cases? To understand that the image is a dotted line. Must and should, while the drawing of examination, dotted line means it is a virtual image. Erect means the same erect. Virtual, erect and magnified image is found on the same side of the object. So these are the important cases for the drawing of ray diagrams of formation of images by the convex lens. And also some more questions are given in textual questions. These textual questions are also there. They complete the picture for the diagrams. This is a diagram of the ray diagram of the concave lens, symbol for concave lens. While this AB is the light ray, divergent ray. The divergent ray can be there. It is parallel to that can be divergent. The light ray divergent must and should pass from focus. This is the 1 mark questions for that or 2 mark questions. Again, the light ray passing parallel to the principal axis after refraction appears to be diverging from the focus of the lens. Again, next one, another question, that is different situations of the objects, that is N1 and 2 points are there. These are the object is situated and image. The first dot indicates the object, the second dot indicates the image. This is the case of the simple microscope. That is sixth case. Because the object is between optic center and focus, the image is erected image, virtual erect image. Now another question is there. That is the question. The 2 points S1, S2 are given, but the point S is above the principal axis is a very, very smaller height. But the S2 is the size is very maximum. So that indicates which case I think that is the object is situated between the focus and the center of curvature. That's only at the magnified image. So the two light rays of refraction of a meet at a point, that is the images can be formed. Okay, another one. Complete the ray diagrams of the following. Another question, that is, this is also question also. This type of question also given in previous examinations, either it is the pre-final examination and also pre-public examinations also there. Now, but this one is the convex lens. The light rays, these light rays are after refraction. What happening? Very simple. So that is converging. Those two light rays are meet at a point on the focus. Now this one. This is diverging because after refraction the light rays are diverged from the concave lens. This is the question. Now another one. Now this is the question is given. How to the form image can be formed? This is a concave lens. This is a symbol for concave lens. And the light only one light ray is given. But images can be formed. How many light rays are needed? Minimum 2 light rays are needed. The one is parallel to principal, that is diverged. The divergent light ray compulsory pass through focus. Okay, that's why that can be pass through focus only. Now another light ray must and should pass through optic center. Yes, optic center. These two light rays are intersect at which the image can be formed. What is the image is? Always virtual, erect and diminished image. So these are the questions are there. Now these questions are must and should follow that 1 mark or 2 marks and 4 marks for difference between the convex and concave lenses. Okay. Now again, the last one, that to show the path of the rays of refraction, what happened? After refraction, what happened? But it is not a parallel rays. It is a parallel, some angle to the principal axis. So what happening? This is the symbol for convex. When any light ray, it is converging at focus. Okay, very good. Now light ray can be focused. But how the image can be formed? How many light rays are needed? 2 light rays. Another light ray must be drawn along the optic center. Now it is the position, like the diagram. Now it is passed through optic center. After refraction, these two light rays are meet at a point that is above that at center. It is called as focal plane. It is called focal plane. Focal plane. The plane which is passed through focus, this is called as focal plane. In the same manner, the light ray, it can be diverged. This is a concave lens, so it can be diverged. The light ray can be diverged. That how much that light ray compulsory pass through diverge. Yes. Again, another light ray pass through. These two are intersect at which image is formed. So that is called, this line is called focal plane. Focal plane. Thanks for to express our sincere thanks to the Gurukulam for the giving this opportunity.